right, we're going to now look at some problems of some things that you're going to be trying some problems on your own here in a little bit. And the first thing I have here, it says the scale of a room in a blueprint is 4 inches to 7 feet. And I highlighted that because that's going to be some important information that we need to use for our problem. It says a wall in the same blueprint is 24 inches. We need to complete the table. Well, one way that we can complete the table pretty easily is I can see that they have some numbers up here, so I can see how we're going to go from a 4 to an 8. So what do I do from a 4 to get to an 8? I'm multiplying by 2. So I can just multiply my 7 times 2. So 7 times 2 is going to give me a 14. So I'm going to write a 14 there. Okay, to go from the 4 to the 12, I'm multiplying by 3. So 7 times 3 is going to give us a 21. 4 times 4 gives me 16, so 7 times 4 is 28. And this should look kind of similar to some of the tables that you worked on when you were doing proportional relationships a couple months ago. So what do I do to the 4 to get to the 20? I multiply by 5, so 7 times 5 is going to give us a 35. And then what do I multiply 4 by to get to 24? That's a 6, so 7 times 6 gives me a 42, okay? So we're going to use this table to answer our next question that we have here. It wants to know how long is the actual wall? Well, the wall in the blueprint is 24 inches, and it just so happens that up here we have 24 inches listed for our blueprint. Okay, so the number that corresponds with that from the actual length is the 42. So the actual wall is 42 feet long. Now, you're not always going to be able to have this table to look at, and sometimes it's not always the best way to set up a table to figure out your problem. The easier way to do it is to set up a proportion like was in the very first video that you watched. So this says a window in the room has an actual width of 3.5 feet. Find the width of the window in the blueprint, okay? So I'm going to go back and I'm going to use this scale again. So I'm going to set that up first. So I'm going to say 4 inches, and I'm going to put it over 7 feet because I want to write my ratio like a fraction because it's easier to use it that way, especially when we're setting up a proportion. Equals. Now, again, back when we were setting up proportions to solve some word problems, remember I told you to make them goof-proof so that you knew exactly where your numbers were going to be. So I'm going to make this goof-proof before I do anything else. Remember, if this is inches over feet, then this side has to be inches over feet. Goof-proof will help you not make some silly mistakes. Okay, so this says the window in the room has an actual width of 3.5 feet. Now, also what you can do is you can think about this 4 feet is talking about, or 4 inches, excuse me, is talking about the blueprint. So my top numbers are dealing with the blueprint, and you could even, jot something down there so you remember that's the blueprint. And then my bottom numbers in my ratio are the actual numbers. So you could put that there too if that helps you. Okay, but so we know the actual width is 3.5 feet. So here, making it goof-proof is helping us realize that that feet, the 3.5, has to go down here for the feet unit. Okay, we're looking for how long it's going to be or what's the width of it in the blueprint. So we're going to cross multiply here. I always do my diagonal. It has my variable first, so I'm going to do 7 times x is 7x. Remember, we want to keep our variable, or we like to have our variable at the end over on the left-hand side, so I just put it there to begin with. So 4 times 3.5 is going to give us a 14. You can use your calculator if you need to figure that out. I just have this little mini equation. Remember, solving a proportion, we need to get x by itself. This is 7 times x, so to undo multiplication, we're going to divide. So I'm going to divide both sides by a 7. And so the 7's divide out, just leave me with the x equals 14 divided by 7 is going to give us a 2. And then if I go back up here, because if I made it goof-proof, I know what my unit is because x is dealing in inches, so it's going to be 2 inches, and I can also fill that up at the top. Okay, and hopefully you're filling this out as we're going along here. Remember, if you have any questions, you can always go back and rewind the video to watch it again to see what you might have missed with the problem. Okay, all right, well, let's look at our second problem here. So this one says a game room has a floor that is 150 feet by 30 feet. A scale drawing of the floor on grid paper uses a scale of 2 units to 5 feet. So what are the dimensions of the scale drawing? So when they're asking us for the dimensions, that means we need to find both the length and the width. Okay, so it says enter your answer as length by width. Now that was in a different program where I got this problem from. We're just going to do it by hand here. But I do have my scale. I'm going to highlight here. So again, there's my scale, is 2 units to 5 feet. All right, so since I need to find a length and a width, I have to do 2 little problems here. So I'm going to set it up. So 2 units over 5 feet. And again, before I do anything else, I'm going to make it goof proof. So this is going to be units over feet. Remember, how you have one side set up, the other side has to be set up the same way for a proportion. So let's see, we're looking for what are the dimensions in the scale drawing. The scale drawing is the on top there with the units, but we have 150 feet. Again, feet, 150, that has to go down in our denominator here of this side of the ratio, or this side of the proportion, I should say. We're looking for our x, all right, for our scale drawing. So I'm going to cross multiply. Again, I'm going to do this one first. So 5 times x gives me 5x is equal to 2 times 150 is going to give us 300. So I'm going to divide both sides by a 5, and that's going to give me x is equal to 5 goes into 30 6 times, and I could have my 0, so I get 60 units. Okay, so I'm going to write a 60 up here. All right, I'm going to do my other side the same way. I'm going to set it up with 2 units over 5 feet because my scale does not change. But this time I'm going to be looking for the width, so I'm going to set it up to make it goof proof. All right, so 30 feet, so 30 goes down there with the feet. I'm going to have an X there for my units for my blueprint or my scale drawing that I have. All right, so again, if I cross multiply, I'm going to have 5x is equal to 2 times 30 is going to give me a 60. I'm going to divide both sides by 5, divide both sides by the coefficient, remember? And so that's going to give me x is equal to 12 units this time. Okay? All right. Again, you can rewind if you have a question, if you need to look at it again. Again, hopefully you're filling out your note sheet as I'm doing all these problems. Okay, so let's look at the third problem that we have here. So it says a scale drawing of the White House is drawn on grid paper. The length of one square on the grid paper represents 7 feet. Now, we have a scale given to us here, but it's kind of hidden a little bit. It's not quite as obvious as the other ones, but right here is my scale. Okay, 1 square on the grid represents 7 feet. We want to know what is the actual length of the White House if its length on the drawing is 24 squares. So I'm going to set up my proportion again, start with my ratio for my scale. So I have 1 square, and that represents 7 feet. So over 7 feet equals, again, we're going to make a goof proof. So I'm going to have squares over feet. Okay. All right, and we have what is the actual length of the White House if its length on the drawing is 24 squares. Right here, squares has to go on the top. No question. Okay, we're looking for the actual length, so I'm going to put an X there. So when I cross multiply here, I'm going to do this diagonal first because that's where my X is. So 1 times X is just going to give me an X equals, if I multiply 7 times 24, you can do that in your calculator if you need to. We should come up with 168. And our unit there is feet. Okay, so the length of the White House is 168 feet. I don't know if that's actually true. This is a problem from a math book, so hopefully they check that out. All right, so it says what is the actual height of the White House if its height on the drawing is 10 squares. So again, I'm going to set up as 1 square over 7 feet is equal to, I'm going to make a goof proof with squares over feet. So it's 10 squares. All right, I'm looking for the amount of feet. Okay, so if I cross multiply here, again, I'm going to do this diagonal first this time. So 1 times x just gives me x equals 7 times 10. A little easier than the first one. We get a 70. Our unit, if I look there where x is, it was feet. So the height of the White House is 70 feet, at least according to this problem. Okay? All right, last one we're going to look at here. So this one's a little bit different. It says, suppose a model of a dragonfly has a wing length of 4 centimeters. If the length of the insect's actual wing is 6 centimeters, what is the scale of the model? So this time we're trying to find the scale. Okay, so when we're looking for a scale, we want to have a unit of 1 up at the top for what we're trying to find. So I'm going to use this. All right, so this is the model. So I want the model on the top. So I'm going to start it as 4 centimeters. Okay, and this is from the model. So I'll put model there. And then this is going to be from the actual. I'll abbreviate actual there. So the actual insect's wing is 6 centimeters. Okay, now to figure out what we want on this side, remember, we're gonna make it goof proof, but that doesn't help us a whole lot because everything's in centimeters, okay? But again, I have to remember that this is the model at the top and the actual down in the denominator, okay? When we wanna do a scale, for my scale model, I want a 1, so I'm gonna put a 1 here. I'm gonna be looking for what this is going to give me down below for my actual. Okay, so I'm going to cross multiply. So I'm going to do this diagonal first. So 4 times x gives me a 4x equals 6 times 1 is going to give us a 6. Okay, I don't have x by itself because we have the coefficient of 4. I need to divide both sides by that 4, and that's going to give us x is equal to 1.5. Okay, so then the scale that we're looking for, all right, our scale is going to be 1 centimeter, and you can write it using the colon if you'd like, since that's how a lot of our problems are written here, to 1.5 centimeters, okay? So a little bit different because this time we're looking for the scale. All right, so some of the problems that you're going to be solving here in a little bit are going to be similar to these, so come back and rewatch the video again if you have any difficulties with those, okay? Goodbye.